Nobody gave them a blueprint. There was no teacher. No older civilization to copy from. No manual handed down from somewhere wiser. Just a flat, salt-bitten, flood-prone strip of land between two unpredictable rivers in what is now southern Iraq, and a group of people who, within the space of roughly 400 years, invented writing, mathematics, the city, the wheel, the concept of law, and the very idea that human beings could organize themselves into something larger than a village. 400 years. Shakespeare to the present day. That's how long it took. No other civilization on record has ever moved that fast. The place was called Sumer. And the mystery of how it appeared, so suddenly, so completely, so far ahead of everywhere else, is one of the most compelling unsolved puzzles in all of human history. To understand just how strange this is, you need to understand what the world looked like before Sumer. For thousands of years, tens of thousands of years, human beings lived in small bands, then small villages. Technology crept forward the way everything biological does, slowly, painfully, generation by generation. A slightly better axe. A slightly more efficient pot. Progress measured in centuries, not decades. Then, around 3500 BCE, something happened on the Mesopotamian plain. It didn't happen gradually. That's what makes it so difficult to explain. When 20th century archaeologists first began excavating the ancient city of Uruk, Sumer's greatest city, they expected to find the usual story. Primitive giving way to slightly less primitive. The slow climb. What they found instead were the earliest identifiable layers of the city already containing fully developed administrative tablets, standardized accounting tokens, cylinder seals, and evidence of industrial-scale craft specialization. The warm-up act had been cancelled. The civilization arrived, as one scholar put it, essentially complete. So the question becomes unavoidable: where did it come from? The honest answer begins not with mystery, but with mud. For nearly 3,000 years before the Sumerians, the southern Mesopotamian plain was home to people archaeologists call the Ubaid culture. They were farmers. They lived in small villages. They made beautiful painted pottery. They buried their dead with care. By any measure, they were ordinary Neolithic people, and they were the direct ancestors of the Sumerians. But at the ancient site of Eridu, the oldest continuously occupied city in all of Mesopotamia, dating back to around 5400 BCE, the Ubaid people had been doing something that wasn't ordinary at all. They had been building temples. One on top of the other, each generation constructing directly over the last, each version slightly larger, slightly more elaborate than the one beneath it. 18 superimposed temples on the same sacred spot, built over millennia. This was not random. This was organized, intentional, and deeply continuous. Something with direction was already happening. Long before writing. Long before cities. The impulse toward organized complexity was already there, building quietly, layer by layer. What changed around 4000 BCE was scale. By 3500 BCE, Uruk had become the largest human settlement on Earth. Population estimates vary, but the city may have housed as many as 50,000 people. To put that number in perspective, London would not reach 50,000 inhabitants for another 4,000 years. Nothing comparable existed anywhere else on the planet. Uruk was not just the biggest city. It was the only city. It had invented the concept. And here is where the environment becomes crucial, because Uruk's rise happened in spite of its location, not because of it. The southern Mesopotamian plain has almost no natural resources. No stone. No metal. Very little timber. The rivers flood violently and without warning. The soil in many areas is so salty that even modern agriculture struggles with it. If you were designing a location for humanity's first great experiment in civilization, you would not choose this place. You would choose somewhere richer, somewhere gentler, somewhere more obviously hospitable. And yet the very harshness of this environment may have been precisely what forced the breakthrough. The Tigris and Euphrates rivers are not like the Nile, generous, predictable, dependable. They flood catastrophically and erratically. To farm this land it all required irrigation canals. And digging canals, long, deep, maintained canals, is not work a single village can do. It requires coordinated labor across multiple communities, which requires planning, which requires authority, which requires someone to be in charge, and someone to keep records of who did what, and who is owed what in return. The environment, in other words, selected for complexity. It punished disorganization and rewarded coordination. And as coordination grew, it needed tools. The first tool was accounting. Across Mesopotamia, archaeologists have recovered thousands of small clay tokens, simple geometric shapes, each apparently representing a specific quantity of a specific commodity. A sphere for a measure of grain. A cylinder for a jar of oil. These tokens had been in use since at least 8000 BCE. They were the world's first data storage system. Around 3500 BCE, administrators in Uruk began sealing groups of tokens inside hollow clay envelopes to prevent tampering. Then someone noticed that pressing the tokens into the soft clay before sealing it left readable impressions on the outside. Which meant you could check the contents without breaking the seal. And then came the leap that changed everything. If an impression on clay could represent a token, why use the token at all? Why not make the mark directly? Within 2 or 3 centuries, that simple insight had evolved into the world's first writing system. Cuneiform, wedge-shaped marks pressed into wet clay with a cut reed, went from purely administrative notation to something approaching true written language. Names. Places. Quantities. Obligations. Eventually, stories. And the very first things human beings chose to write down were receipts. Inventories. Payroll records. Not poetry. Not prayers. Spreadsheets. This tells us everything about what was driving the transformation. The engine of Sumerian civilization was the temple, not purely in the religious sense, though religion was absolutely central, but in the economic sense. The great temples of Uruk and Ur and Nippur functioned as what a modern economist would recognize as redistributive institutions. Farmers brought their surplus grain to the temple. The temple stored it, processed it, and redistributed it. As wages to craftspeople, as rations to workers, as seed grain for the next season. The temple owned land. It employed people. It managed supply chains. It extended credit. The word for interest in Sumerian, mash, originally referred to the offspring of livestock. Money that breeds like animals. These are not naive people. This is sophisticated economic thinking, worked out from scratch, in a language no one had ever written before. And yet Sumer had almost no raw materials of its own. So how did it build on the scale it built? The answer is trade, and not just local trade. Between 3500 and 3100 BCE, Uruk established trading colonies and outposts across an enormous area. Into Anatolia. Into Syria. Down into Iran. Uruk-style pottery, Uruk-style administrative tablets, Uruk-style architecture, all found hundreds of kilometers from Uruk itself. Timber came from Lebanon. Copper from Oman. Lapis lazuli from Afghanistan. The Uruk trading network was, in effect, the world's first globalized economy. And the diversity that came with it, different peoples, different languages, different knowledge systems converging in one place, may itself have accelerated the pace of innovation. Communities attempting to trade across language barriers need standardized systems. Standardized weights. Standardized symbols. Standardized rules. The multiculturalism of early Uruk may have been one of the engines of its brilliance. By 2900 BCE, Sumerian civilization had fully flowered. The royal tombs of Ur. Excavated by Leonard Woolley in the 1920s, revealed gold headdresses, lapis lazuli jewelry, elaborate musical instruments, and the disturbing evidence of mass human sacrifice, servants buried alive alongside their rulers. A reminder that complexity is not the same as progress. The same administrative genius that organized irrigation canals also organized coercion. Both things were true simultaneously. And then, the long aftermath. Sumer was eventually absorbed. By the Akkadians, the Babylonians, the Assyrians, the Persians. Each new empire built on foundations laid on that flat and featureless plain. The cuneiform script survived for 3,000 years after Sumer's political eclipse. Babylonian mathematicians working in base 60, which is why we still divide the hour into 60 minutes and the circle into 360 degrees, were building on Sumerian mathematical traditions. When the compilers of Genesis wrote of a great flood, they were drawing on Sumerian flood narratives already 2,000 years old. The invisible architecture of Sumerian thought runs through the entire ancient world, and through ours. So was Sumerian civilization truly sudden? The antecedents were real. The Ubaid people, the accumulating pressure of irrigation agriculture, the slow build of complexity over millennia, all of it was there. But the final compression, the speed of that last leap into full civilization, remains extraordinary by any measure. The system reached a tipping point, and then it moved. Ordinary people, in a difficult place, solving practical problems, trading ideas across the boundaries of language and culture, and in doing so, building, almost by accident, the conceptual infrastructure on which everything since has rested. Someone pressed a reed into wet clay. Made a mark that meant grain. Made another that meant 30. Handed it to someone else, who understood it completely. 5,000 years later, we are still doing exactly that. If this made you think differently about where we come from, you're in the right place. This is Historia Zen. Subscribe, and we'll keep going back.